Good evening, everyone. Welcome to the Intel booth. Welcome to the end of day 2. You made it. I hope everyone's feet are tired and your head is full of interesting technology discoveries and that you spent a bunch of time here in our booth. Our last panel of the day is really interesting. So it's, as many of you know, 5G promises to be one of the most transformative technologies of the century, enabling industries of all kinds to create new business models and service architectures. Our panel today is going to talk about one of those opportunities, the way that 5G edge computing will deliver on this promise for a new era of cloud services. And I'd like to introduce Sean Kinney from RCR Wireless News, who's going to lead this discussion. Sean?
All right, thank you very much for that introduction. I'd like to thank everybody for joining us this afternoon. You know, if you've been around the Intel booth here, you've probably seen some of the great demos like the Rubik's Cube or the cloud gaming over there. And you know, all of these speak directly to what we're going to be discussing during our panel today, which is this combination of 5G and the edge. So let me introduce our esteemed panelists here. We've got Caroline Chan from Intel. Caroline's the VP of Data Center Group and GM of the 5G Infrastructure Division. Mr. Ian Gillett, President of IGR and founder. And then Rob Topol, who is the General Manager of 5G Advanced Technologies and the Technology Systems Architecture and Client Group. So big round of applause for our panel, and I want to thank you all for taking part in this discussion with us. So before we really dig in here on 5G and edge, maybe let's set a frame and a baseline in terms of terminology. So Caroline, help me understand what the edge is, where the edge is. Is the edge my device? Is it an enterprise LAN? What is the edge?
So when we looked at edge, we looked at where it actually touches where the user experience, the delivery. So it could be on-prem, so that could be means millions of points, access points on-prem, or it could even be off-prem. Mainly, we look at the edge is based on latency. What sort of latency you need to deliver the services, and we actually have a very good picture showing the entire network demarcated by latency requirements. Where the server's latency needs to be, that's what the edge that we call.
Okay, so now let's talk a little bit about how cloud fits into edge. So a lot of times, Rob, when you think about cloud, you're thinking of a data center that's somewhere far away. But with edge, to really open up some of these latency-sensitive use cases that you think of when you think of 5G, you need to move that compute and that processing closer to the end user. So can you expound a little bit about how you take that data center specialized hardware and then bring it out closer to the end user?
Right. So with 5G, you're seeing essentially a technology that was born after the cloud. So it's the first wireless technology that can take advantage of the orchestration structure that's been in place for cloud and servicing users, and now taking the virtualization technology that exists in a data center of how capacity is allocated, and you're moving that down in this virtualized capacity, as Caroline talked about, at the edge of a network, and now bringing that as a way to provide extremely low latency use cases, applications, and services that 5G essentially brings. And that's, of course, in partnership with the enhanced mobile broadband aspects of 5G. So when you combine those two, now with the fact that you've got an edge computing platform nearby, the new applications and services are really limitless.
And Ian, you bring a really unique perspective to the table. I know you have conversations with global operators and all of their ecosystem partners. So maybe tell us a little bit about what the strategy for building out the edge is going to be. Do you think this is something that the operators are going to want to own? Is edge going to be delivered as a service? Or is edge something that's going to be provided by our traditional cloud providers?
All of the above. So it really depends on Caroline's point about where that edge is and the latency. So some applications are going to be very, very low latency, autonomous vehicles, some of those type of robot control, things like this. And you want to get as close to the radio as you can. Mm-hmm. In that case, you're going to work with an operator very, very closely because they've got the radio. In other cases, maybe you can be a little bit further back in the network, have a little bit of a bigger cloud data center, maybe at a city level or a neighborhood level. Maybe now it's outside the carrier network that you connect in. So Yes.
Yes.
is the answer, but it's going to vary by application. I think it's going to be difficult in some ways for the cloud providers to say, okay, now we're going to be in the radio business and go get all these sites. And likewise, it's very difficult for the carriers to say, we're going to be in the cloud business and go build massive data centers. So they both need each other. There's a natural partnership there.
So it's going to be a complex relationship that we see develop over time as the edge gets built out, 5G scales. So, I'm curious, Caroline, I know Intel is constantly engaged with your clients and your partners to run proofs of concept and trials. So what are some of maybe the key learnings you could share with us that speak to that relationship between 5G and edge?
So when I looked at 5G, I know Rob and team done a great job driving the next generation standard, defining the air interface. I always look at 5G more than just an air interface. It's really a transformational, especially around digital transformation. So lately, I've been spending a lot of time talking with different enterprises, talking to casino owners and so on. And we found is that the enterprise really becoming the key decision maker in this. You don't just say, well, would you roll out 5G? The question really is about what can 5G do for them? So edge compute becomes the multiplier of 5G. 5G should be, through network transformation, should be a connected mini data center or mini cloud that services the enterprise. Because we all want to talk about monetization of 5G beyond the consumer, and that really becomes a key component. And our learning has been that we engage enterprise directly, find out their problem statement, their pain statement, and we bring it back and solve that with the operators and with our partners in the OEM space. In some cases, we even brought in the cloud service provider. I have some interesting cases going on right now with the cloud service provider. We can talk about that later.
Well, yeah, Intel put out a ton of news this week. It was hard to keep up, but something that really jumped out at me was the relationship that you're developing with Alibaba ahead of the Tokyo Olympics. And the news items I read were really geared towards the inclusion of artificial intelligence in a lot of this. So if you could apply that to Edge, does Edge require AI to really be a sound investment, or can one go forward without the other?
AI and 5G, I think really goes hand in hand together. So we currently have been working in China with Alibaba as well as Baidu. We announced both of them, putting AI on 5G, putting blockchain on 5G. Security becomes a key important thing. Last night, we did a pilot with NHL in the game of Golden Knights versus the New York Rangers, where we put up a real-time in-game wagering system. No one was making bets, by the way, but it was a simulation of putting all the partners, the software partners, running that on a connected edge compute network that's showing you stats that actually happen in real time in the game. So, for example, as the I don't know hockey, so it's gonna be bad. But the pucks all have sensors. The athletes have sensors, so you could tell how fast they're going, the direction. NHL was on stage with me about an hour ago, and they said that prior to this, they have 300 stats per game. With this, they can tell 10,000 stats per game. So what that really tells me is 5G and edge compute is all about data. It's data acquisition, data retention, data analysis, and data monetization. If you think of it in that way, 5G and edge compute becomes a way of a digital transformation for all enterprises. It changes how you utilize your current information, extract more data, retain the data, analyze the data, and eventually make money off those data.
Hey, Sean, if I could add as well to what Caroline's saying, that's why Intel has focused so much on field testing 5G and taking many of these use cases, out of the lab into a physical environment like the NHL, T-Mobile Arena last night. We do that because we're trying to put 5G into the hands of enterprise, into consumers, where they can directly interact with that technology and look at the new ways that the uses can evolve our behavior and the things that we do. And the role of edge and AI is that AI is about human interaction, human cognition, thinking, and learning. The closer that computation and activities happen to us as users, as endpoints, the quicker you start to see a digital assistant, personal assistant, that type of functionality close to us. Edge is what enables that, not only as a workload, supporting what's happening in the edge, this mini cloud we're talking about, but AI is also to improve the overall productivity, the learning, the function of how edge operates. So it's not only a catalyst to the way that it functions, but it also supports AI as a workload that's coming from us as users.
So, Ian, what's your perspective on this relationship between edge and AI? Based on your conversations with operators and other stakeholders, are they considering them in tandem?
They do, but from a different perspective, because from an operator perspective, they've got to run the network, which is going to have large cells and lots of small cells, and low latencies, and a lot of users, and a lot of devices. So AI, from their perspective, comes in from a network operations point of view. It's getting so complicated that you've got to apply the AI to that. On top of that, you then say, okay, I'm going to give AI with 5G to the developer. Now they can start layering those applications on top as well. So it's interesting because if you go to an operator and say, hey, let's talk about AI, you've got to say, I'm talking about the applications, not necessarily network operations. They're different things. But I think Caroline's example is a really good one here because a lot of people say, well, why do I need edge with 5G? What am I going to get that's new, right? Well, you've got a stadium with 50,000 people in it. That's a lot of bandwidth in one place. I mean, that's going to be tough for a current network to deal with. But the high bandwidth with 5G will deal with that. Well, then you're going to want to put video cameras on the players' helmets and feed it to the audience. Then you start applying the analytics of the data, the 10,000 data points. Then you put the betting on there, the wagering. And suddenly now you need an analytics platform sitting there. That's the edge. So it makes no sense to take all that data, send it to a cloud somewhere else, process it, send it all the way back. A, it'll take too long, and B, you're using a lot of bandwidth that could be done locally, and you get a better response. So.
Yeah, precisely. Last night was showing is that in a screen, you have the game going on, and for every, the puck as well as every player, you can click on it and show you the speed and in the game what he's doing in real time. And if you want to make a bet, for example, I want to bet how many times this athlete will actually assist in a goal, immediately they give you back the odds and the payoff should you place a bet. And then there's a button to say, place a bet. That kind of interaction, the real time, the analytics, because you have to be willing to put a bet on the odds on whether they're going to do it. So all of that real time, low latency is where 5G comes. Edge compute comes in because of analytics. You'll be able to take the bets and provide a payoff. The secure online transaction aspect is huge in this. And you can take that onto the financial market as well. Not just, this is just an example, a pilot. Take the learning and apply that to something like an online transaction.
Well, I'm really excited about losing money on ill-informed sports betting in more creative ways and more quickly. But how can you mention fintech, but tell me some of the other use cases you're tracking that you really see creating value within enterprises and industries in the short term.
Smart factories. There's a lot of money to be spent. Industrial 4.0. Smart cities, and smart cities is not just the city paying for it. In fact, we have taken smart city transit to smart roads, smart transportation. We've announced a project in China with Alibaba to help them work with part of the first wave of partners with Alibaba to define the smart roadside unit as part of the Chinese national standard. People are looking at how to better manage the traffic congestion situation, traffic safety. The government in China set up a zero road death target a couple years out. So a lot of things are happening where you need that kind of a real-time information, analyze it in order to direct the traffic elsewhere. I'm not talking about autonomous driving. I'm really talking about some kind of V2X, and all of that needs some real-time information capturing the smart camera data. So we partner closely with our IoT groups, with our cloud group, and working with our customers and to make that happen.
And Sean, to add, it's something we've actually tried to do in the booth today, is if you walk around and look at some of the demonstrations, we're looking at ways to bring, whether it's cloud gaming capability utilizing a local edge compute platform, whether it's a tactile augmented reality experience, or a hologram where it's a collaborative experience. Again, all of these utilize edge as a compute platform and basis to do that type of local rendering and support. But I would say you asked about learnings earlier, and what we're finding is that as you move towards 5G and the way our behavior and use cases are evolving, we're not only consumers anymore of information and data that's coming down through a downlink, you're starting to see more production, uplink, whether that's from sensors, it's from the added, computation and smart connectedness that happens around us. So now there's more information coming up from endpoints. And again, the proximity of edge computing to be able to quickly do evaluation, analytics, provide better information, whether it's for productivity, efficiency, many of the cases that Caroline mentioned. That's essentially what we're trying to show is sometimes it starts with a consumer example, but we quickly apply those into an enterprise or an industrial environment.
Yeah, Rob, you and I spent some time playing with Rubik's Cubes earlier today, and it's a wonderful demonstration that really shows you what can happen when you combine 5G with AR, with tactile feedback. But if you could maybe expound on that a little bit, it is, for the purposes of this, very demonstrative, very broadly appealing, but you can apply that same set of technology and really create tremendous value in some industries and enterprises that would just truly benefit from the digital transformation that can bring.
Right. In many cases, these demonstrations are to bring a remote capability or something where we're isolated, we're not close in proximity. It brings collaboration together where people thousands of miles apart can collaborate and work on something together. And the Rubik's Cube example we had in partnership with Nokia Bell Labs was a great one of showing how you can essentially use an augmented reality for a lot of training purposes. And we see high application as that goes into an industrial environment for training of learning how to do hands-on, where you have an object in your hand and that's rendering to a different object that's in the factory, types of training, knowing where things are, to where that person then, when they're put into that physical environment, it's a running start, right? They're ready to do that job at a high productivity level. So it was a great use case and example.
Yeah, so Ian, we've called out a number of use cases here. I'm curious if what we've discussed so far is consistent with what you're hearing from the operators that you've spoken to in terms of what they can do in the near term to monetize while still delivering an experience that showcases their investment in 5G.
Yeah, again, it's going to depend on who you are and where you are in the world, which some of the bigger operators are launching 5G earlier than others. The initial launches are for the enhanced broadband. So we don't have the lower latency stuff yet. That's going to come probably next, what are we in,
Release
2019?
16? Release 16 will come out,
release
right?
16, so that's 2020, which sounds really long way away, and then you remember that we're actually in 2019, so next year. So I think enhanced mobile broadband first, put the low latency on top with that secondly. Now you combine the two of them, then put the massive machine learning, the machine sensors, putting more devices on the network strains the network from a signaling point of view. So that's why we need an upgrade for that. So late next year, 2021, it all comes together. The applications I always like, I think are very easy for people to imagine are augmented reality, virtual reality gaming. So take your favorite game, put a headset on, now you're moving. That needs low latency. It needs image rendering, which is massively computationally challenging, right? We need bandwidth to get to the headset. And then you want to put all the analytics together with it. But not just sitting together in a room playing, but I'm here, my son is in California, my daughter is in London. and we're all playing the same game in real time, virtual reality, and that's the type of thing we'll be able to do. I think the operators actually, they know what they've got from a capabilities point of view. They've got some ideas of what they can offer with it, but at the same time, they know that there's very creative people out there who can take those capabilities in that platform and develop on top of it, just like happened with cloud and the internet and all those things. And I think I always joke that, there's going to be a few 20-year-olds in a garage throw pizza in every so often, and applications will come churning out, which will take advantage of bandwidth, latency, and the computational aspects and the IoT.
And so this is a question for the panel here, but right now a lot of the operator CapEx is focused on densification of the radio layer, adding in small cells and activating millimeter wave and the various different spectrum holdings. Are they making the necessary investments today in edge computing, and where does edge go when you're considering your network as a whole? Do you just, every time you stand up a new radio site, do you put some compute power in there, or what are the deliberations that you need to make as you plan your network strategy over time?
Well, I'll go first, and I know, Ian, you probably have a lot to say. I've been a little frustrated there is like you said, everybody focusing on the densification part. Luckily, what we have done is do something called network transformation. So a lot of the 5G network are more and more looking like cloud native. So that's a great step forward. What we're still missing, I think the entire ecosystem missing, is that we have not honestly gone out to the enterprise and asking what is the hurdle. In fact, just at noontime, I met with a very prominent group of very large corporation here in the U.S., and they own a lot of vending machines. They're right now about to upgrade from 3G, and what do they upgrade to? They want to upgrade to 5G, but they're concerned. So we need to do a better story and to tell them how this network transformation means that you are an evergreen. It's a general purpose server that you deploy out, and it's a software upgrade rather than, because they were concerned that if I roll out now and then 3 years later something changed, do I have to rip everything out? We have to do a better story telling that. Edge compute comes with a network transformation. You are running a cloud native. I always tell people it's a connected cloud that follows you. It's a mini cloud that follows you. If we tell a story like that, the enterprise will be much more willing to accept and adopt 5G much faster.
Okay.
Yeah.
So you mentioned the densification. A lot of that comes from the fact we're starting with millimeter wave. Those wavelengths don't go very far, so therefore we have to have a lot of cells. So that's where that's physics.
The physics,
right?
yeah.
We can't change that. I was joking with somebody that Stephen Hawking is dead, therefore we can't change the rules of physics anymore. But with that densification, the other part is to put in release 16, which is that next generation core, which has got the low latency aspects to it. That is a virtualized platform. Some operators are actually virtualizing their 4G core today so that when they put the 5G core in, it's just a software load. They can load it up straight away. Others are going to wait till they get to the 5G core next year before they virtualize. So there are steps happening today, but once we've virtualized that packet core, now I can spread it around the place. I can distribute it. So then I start to say, okay, I want some of that compute power, that core down at a baseband processing center, maybe at a big macro cell site, maybe in the bottom of an enterprise building, Class A commercial space. I can deploy that as a virtual machine once I've deployed the hardware, and the hardware is a server and storage. So we're putting the answer to your question is yes, we're putting all the pieces in place. Some people are doing it, they're doing B before A. Some people are going to do A, then B. It depends on where you are in the world and what stage you're at. And a lot of it is driven by what spectrum they've got available and how much they've invested in LTE and where they are with their LTE adoption and deployment as well. It's very easy in the US to think that everybody around the world uses LTE, and there's a lot of places where the growth curve on LTE is still very, very steep. Yeah. There's a lot of adoption there to come before they get ready for 5G. But that step is still only 4 years away, 2021, 2022. We're not going to have to wait till 2030 or anything like this. So.
And that's why the use case research is so important as well. And you're seeing a lot of the operators do some due diligence of looking at the fact that if this is a decade-long air interface, this is probably not about the smartphone. So thinking about how early scaling might happen with the existing devices and things around us, but really the broader adoption and scale of 5G is going to be driven by new types of devices, new interaction. We're going to have the ability to interact with more connected things around us that won't just be in our pocket. It's important to think about that because you see the operators taking different strategies, as Ian said, whether it's B before A before B, because they're looking at, are they applying use cases that require density? Are they looking at initial use cases that require coverage? Are others focused on reliability or low latency? It's all about the new applications and services that 5G will deliver. And you're seeing, it's refreshing to see the different telcos look for a specific strategy and segment. It shows how broad the scope and breadth is of 5G, that you can do that. You can target different segments to essentially build those networks.
You know, I wanted to bring this up, and I think that's a great intro point, Rob. Network slicing is something that's been discussed hand in hand with 5G for a long time, yet still a little ways away. I guess to give maybe a very brief definition of this, you could think of it as connecting any device to any cloud service over a bespoke data pipe that's available on demand. What kind of coordination do we need to have between our cloud providers, our telcos, and everyone else in the ecosystem to make that viable when industry and when enterprise needs it?
I can give a quick first answer. I would say it depends on how far you want to take the quality of service as essentially a metric. So think of it as if you're starting with the example of slicing, that it's to improve the functions for a highly connected, autonomous, cooperative driving vehicle, and that being used, nearby a college campus that has tremendous download and upload activity happening, and being able to guarantee that there's a certain quality of service. The question is, when you talk about the cloud service provider and the communication service provider, how far do you want to go to an application layer of quality of service? And that's when the orchestration that happens in the cloud, working through the network, essentially down to the air interface to the endpoint, and that response back and forth. How far you want to take the application quality of service, I think, is how close those two partners have to work together.
And the other side to this is we can do network slicing today, right? So if we want to say to Caroline's NHL example, okay, there's 50,000 people going into that stadium for a game. I know the schedule of when that's going to happen. I know when the Super Bowl is every year, right? I can plan for that, and I'm going to put more network resources into those facilities, into that football game, hockey game, whatever, scheduled, right? That's network slicing, but it doesn't need huge amounts of dynamic processing or on-the-fly changes to the network. It could be that we want to do something every weekend in a certain part of the network, right? So those things can happen today, the scheduled or the planned. What's difficult with network slicing and what you're talking about is the dynamic on the fly. So something happens, I want network resources right here, right now, guaranteed. And that's difficult, and that takes coordination, as you said, between the cloud and the service providers. I mentioned earlier about spinning up virtual machines. It sounds easy, doesn't it? Just spin them up, right? But the amount of coordination to do that, and planning and network planning and software, it's very, very complicated. So the challenge here is really one of software, have A, the compute resources in the right place, but B, the ability to control them. The other thing with edge is that edge applications move. They could be at the edge here, and then Caroline moves. She was at the NHL game last night, now she's here. Maybe she's got a certain application that's going to follow her. There's some applications will only stay in one location for security reasons. An enterprise may want 5 locations, but only those 5. And some things have to control all this. It's got to be secure and it's got to be controlled. So that's really the challenge of the network slicing piece. And that dynamic aspect of it will be a while. The static stuff, the planned, easier to do.
The way that I think about network slicing, I always think about it as a function as a service. If the operator in the comm side had to be as successful, think of a model yourself after the cloud. How's the cloud do is that when you want compute, when you need a compute, you get the compute in the instant that you want, and when you don't need it, you return it back. Functions as a service is the extreme, is really what network slicing needs to be. Whether it's a frequency, whether it's a amount of data, bandwidth, think of XLA as a guaranteed SL as a differentiator. So I challenge my team to think of it, deliver me a function as a service on a 5G network. I think if we can do that, then the comm service provider will be as successful as a cloud service provider. Because you go to Amazon, you say you want something now, you fill in a template, fill in a request, boom, you get it, right? You can't say that today about our cell phone service, but we should do that. If you truly want to go to a factory, say, let me take over your supply chain, let me take over your production line, you better be able to do that. Because Amazon doing that today, you should do that in order to get their business.
You know, Ian, I really liked your characterization. It sounds simple, just spin up a slice.
Slice away.
It's easy.
Easy.
Incredibly complex. So,
Yeah.
you know, from each of your perspective, if you're speaking simultaneously to a cloud provider and to an operator, how do you tell them to approach this collaboration over time to get to this end?
Carefully. We've done a white paper looking at this, and looking at the cloud and the edge and the 5G network and what you get by bringing them all together. And it is a case of 1 and 1 and 1 equals 10, right? The cloud providers need the operators and the edge. The operators need the cloud providers. Some companies are working it out. You mentioned Alibaba earlier on is a good example. And there's some good case studies of that collaboration between the operator and the edge and the cloud. But I think that some operators look at it and say, we're not going to be in the cloud business. We never will be, so we're going to have that discussion. I think there's some cloud providers say, hey, I'm never going to be a mobile operator. And so there are natural partnerships there. In some cases, it's going to have to be another third party that brings them together. There's going to be somebody in the middle, probably Caroline, who said, hey, if you work with these guys, look at what they're doing. It's very complementary. I think also there's an interesting view is that some of the operators have very public statements on some things they're going to do and they won't do. Some of the over-the-top providers say we don't need edge or we don't need this. Scratch behind the surface and you'll find that the strategy officers, the strategy departments, all looking at this, all having discussions. It may not be in 2019. They're looking beyond about what comes next. And next is not 10 years. Next is 2 and 3 years. So long answer, short question.
Rob, do you have any perspective?
Yeah, maybe to add to what Ian said, I think that when you start to break down the applications, the services, you really, to bring those closer to consumers, closer to enterprise, you essentially need the workings of both. You need a company that provides mobility and access paired with the way that the CSPs have been so successful with setting up, whether it's a marketplace, it's an advertising function, it's AI services. They've found ways to provide a strong service and value through that infrastructure. And now pairing that with a mobility network that provides just wonderful opportunities with broadband, with low latency. Of course, you're going to see CSPs dabble into the telco space and the access space, and you'll see service providers that want to become and aspire to CSPs, and we already see some of that already. But I do think, as Ian said, this is more of, if you go into the back office, the strategy offices of each of them, they really have a common strategy. They know what they need to do to connect a cloud and an end user. and how to drive benefit from that. So I think we're going to see some interesting partnerships over the next 18 to 24 months as you start to see 5G deployments, you see use cases solidify, and you start to see the role of how the two come together.
In the cases I've seen, the few cases that they work together is the customer. The customer bring them together. So in Intel, we actually providing a software development kit that sits on top of the telco network, abstract the ugliness, the complexity of the telco, and expose that up to the developers. And we allow different cloud adapters because I understand most enterprises have multiple cloud subscriptions. So in order to ease that gap, because the way I look at 5G and edge computing, smart IT meets a smart network, and we want to be the glue in between, make that smartness come together, remove the friction of it. In the cases that we've seen successful collaboration, is because the customer demanded. The customer demanded, and when there is a ROI, and people realize it's not a zero-sum game, it's not you lose, I win, you lose, it actually come together much faster. But we need to provide, we want to be the one that ease that transition, the friction.
Okay, well, we're running up against our clock here, and I know we've covered a lot of ground, but maybe, Rob, we could start with you and just share some final thoughts as it relates to this 5G edge discussion. If you learn nothing else, what do you need to know about this?
Yeah, I mean, I think the main point is that 5G, again, it's about mobility. It's about looking and adjusting an air interface to the behavior that we have as users, as consumers. I mentioned earlier that we're not only consumers, we're becoming producers. And the way that that interaction works and the demands we have for high resolution, high throughput, the fact that most of the workloads of the future on networks are going to be AI and media-based workloads, it's important that there's local computation, that there's ability to essentially bifurcate use cases to where things can be done and rendered in a cloud, and those that require local, essentially multi-access edge computing. And so it's important to think about, there's some exciting use cases that we're going to have the potential to be a part of over the next several years, and edge computing is going to be the platform that drives a lot of that low latency, high immersive media experience for us.
Oh, me now? 5G is a little, there's a lot of hype around right now, and I think Rob's description is very good. This is high bandwidth, where you are, all the time, low latency. And it's happening. So that's the first thing. Second thing is, I'm probably too old to tell you what the applications are going to be. My kids are probably a better idea. But I think as a developer, or if you've got ideas out there, the thing I tell people is, don't worry about all these abstraction layers or all this complexity of millimeter wave and densification and network slicing. You've got a high bandwidth, low latency, massive connectivity capability. What can you do with it, right? And if you look at the developers today, they don't sit there and go, gosh, I wonder how Amazon does this. How does Google Cloud do this? No, they develop the application and fill out the form and off it goes. Do the same thing here, but say, what can I do with mobility, low latency, bandwidth, and massive connectivity, and be creative. My kids look at the world completely differently. They're in their 20s. My son's about to graduate, and he's going to get an apartment. And I said to him, so, what connectivity are you going to get? Fiber, cable modem? He's like, what's that? I'm going to use my phone, like I do now.
Yeah.
Stream football games on LTE. And he's like, Dad, I just want 100 gig a month. It'll do me fine. That's all I need. HD. And he starts at 100 gig, but to his world, that's normal, right? So take that environment and create a way. I think that's the power of what we're talking about here. Don't worry about all the complexity. The industry will deal with the complexity. We can deal with that.
Caroline, final thoughts? Gambling picks?
I trust that 5G will be taken care of by the smart guys over there. The biggest payoff is going to come from transforming the enterprise. Digital transformation is a huge ROI that we need to tap into. I'm going to shift a lot of my focuses to really start working with enterprises in the cloud, really make 5G a de facto ways to, when they think about uplifting their factories, it's not, another cable running, it's 5G. 5G with edge compute is the biggest payoff for digital transformation.
We're going to have to end it there. How about a big hand for our panel and for our host from Intel?
Thanks.